Good morning. Today we have to take one more topic, 11th topic about magnetic material. Magnetic materials. Today we have to see one more topic about magnetic materials. On the last period, on the last year we have studied, suppose this one as a current carrying coil. Suppose this one as a current carrying coil carrying current I or radius of coil. Suppose this one as a current carrying coil of radius R, then this current carrying coil produces magnetic field. This current carrying coil produces magnetic field at center and perpendicular to plane of coil. This current carrying coil produces magnetic field at center perpendicular to plane of coil, and this magnetic dipole moment, the magnetic dipole moment of current carrying coil, that is I into area of coil A. Area of coil, that is pi r square, which is nothing but I into pi r square. हे आपण 11th ला पाहिलेलं आहे. मॅग्नेटिक डायपोल मोमेंट, करंट कॅरिंग अ सर्क्युलर कॉइल produces magnetic field at its center. The magnetic dipole moment of this current carrying coil is I into A. I current flowing through coil A, area of coil. आता याच्या आधारे आपण एक कन्सेप्ट पाहतोय, ती म्हणजेच मॅग्नेटिक डायपोल मोमेंट. मॅग्नेटिक डायपोल मोमेंट of revolving electron. Magnetic dipole moment of revolving electron. In an atom, negatively charged electron revolves in circular orbit around positively charged nucleus. In an atom, negatively charged electron revolves in circular orbit around positively charged nucleus. Let E charge on electron or radius of orbit, phi, that is linear velocity of electron. E charge of electron or radius of orbit, phi linear velocity of electron, then current associated with orbiting electron, current associated with orbiting electron, that is current I is equal to charge on electron divided by time. Current, that is quantity of charge flowing through conductor per unit time. आता इथं आपण काय करतोय, टाइम इज इक्वल टू समजा पिरियड कन्सिडर करतोय. Time is equal to period, means time required to complete one rotation. We know that velocity is equal to distance covered divided by time. Phi, that is velocity of electron in time capital T. Capital T means period. in time of period means one rotation, distance covered by that electron. In one rotation, distance covered by that electron is circumference, that is 2 pi r, which implies period t is equal to 2 pi r divided by v, and therefore current associated with orbiting electron E divided by time 2 pi r divided by v, which is nothing but E into v divided by 2 pi r. Now, area of this circle, area of this orbiting circle A is equal to pi r square, and therefore orbital magnetic dipole moment of revolving electron, orbital magnetic dipole moment of revolving electron is equal to I into A, I's value E v divided by 2 pi r into area of coil pi r square. A car cancel, pi cancel. Therefore, orbital dipole moment of revolving electron is equal to E v r divided by 2. Suppose this is equation number 1. This is an expression for orbital magnetic dipole moment associated with revolving electron. Okay. Now, this is an expression for orbital magnetic dipole moment of revolving electron. Now, one more term about gyrometric ratio. Gyrometric ratio. The ratio of orbital magnetic dipole moment of revolving electron, orbital magnetic dipole moment of revolving electron to its angular momentum. Gyrometric ratio is the ratio of orbital magnetic dipole moment of revolving electron to its angular momentum is called as gyrometric ratio. Therefore, gyrometric ratio m orbit divided by L is equal to orbital dipole moment E v r divided by 2 divided by angular momentum of revolving electron. Angular momentum, that is moment of inertia into angular velocity. रोटेशनल मोशन मध्ये आपण पाहिले पहा, angular momentum is equal to moment of inertia of revolving electron to the into angular velocity. Moment of inertia, mass of electron or mass of particle into distance square. Here electron as a particle, therefore mass of electron into distance square. Relation between linear velocity and angular velocity, v is equal to r omega, and therefore omega is equal to v divided by r. A car cancel, becomes m e into v r. This is angular momentum of revolving electron. Put this value here, we get m e into phi r. Phi ला phi cancel, r ला r cancel. Therefore, gyrometric ratio becomes E divided by 2 into me. E charge on electron, me mass of electron. Therefore, orbital magnetic dipole moment is equal to E divided by 2me into L. Okay, this is about orbital magnetic dipole moment. But according to Bohr's theory of hydrogen atom, angular momentum of revolving electron is equal to integral multiple of h divided by 2 pi. N, that is number of orbit. If electron revolves in first orbit, then n is equal to 1, and therefore angular momentum becomes h divided by 2 pi. And therefore orbital magnetic dipole moment is equal to E divided by 2me into h divided by 2 pi. As all these terms are constant, E charge on electron, h Planck constant, me mass of electron, all these terms are constant. समजा ह्या सर्व व्हॅल्यू जर आपण इथं ठेवल्या आणि जर समजा याचं कॅल्क्युलेशन केलं तर त्याची व्हॅल्यू असते 9.274 एम्पियर पर मीटर स्क्वेअर. बघा, ऑर्बिटल मॅग्नेटिक डायपोल मोमेंट 9.274 ampere per meter square and is called as Bohr magneton. This constant is called as Bohr, B-O-H-R, magneton, and therefore convenient SI unit of orbital magnetic dipole moment is Bohr magneton. This is about orbital magnetic dipole moment of revolving electron. High formula आहे EVR divided by 2. तसा हा पण एक फॉर्म्युला आहे EH divided by 2 into 2 4 pi me आणि याची व्हॅल्यू असते 9.274. This is about orbital magnetic dipole moment of revolving electron. Okay. Now, one more concept about magnetization and magnetic intensity. Magnetization and magnetic intensity. Magnetization and magnetic intensity. See, in an atom electrons not only revolve. समजा या ठिकाणी हा positive charge nucleus. This is electron revolves in circular orbit around nucleus. In atom, electron not only revolve in circular orbit around nucleus but also spin about its own axis. हा जो इलेक्ट्रॉन आहे हा सर्क्युलर ऑर्बिटमध्ये रिव्हॉल्व होतोच, त्याचबरोबर तो स्वतःच्या ऍक्सिस भोवती देखील रिव्हॉल्व होत असतो. इन एन ॲटम, इलेक्ट्रॉन्स आर नॉट ओनली रिव्हॉल्विंग अराउंड न्यूक्लियस but also spin about its position, and hence atomic dipole moment of revolving electron is resultant of orbital and spin motion of electron. The net magnetic dipole moment of revolving electron per unit volume of magnetic material. The net magnetic dipole moment per unit volume of magnetic material is called as magnetization of magnetic material. What is magnetization of magnetic material? The magnetization of magnetic material M is defined as the net magnetic dipole moment of revolving electron per unit volume of material, and therefore magnetization Mz is equal to net magnetic dipole moment of revolving electron per unit volume. ओके, मग आता याचं SI युनिट magnetic dipole moment ampere meter square volume meter cube, and therefore SI unit becomes ampere per meter. Dimensions of magnetization L minus 1 M0 T0 I1. This is about magnetization of magnetic material. Now, consider a rod. Consider a rod of such material. Consider a rod of such a material with net magnetization. Placed in solenoid. Consider a rod of such a material with net magnetization. म्हणजे ज्या मटेरियलला नेट मॅग्नेटायझेशन आहे त्या मटेरियलचा आपण रॉड कन्सिडर करतोय. Consider a rod of such a material which has net magnetization placed inside solenoid. Suppose this one as a solenoid. Suppose this one as a solenoid like this. Suppose this one as a solenoid. Suppose this one as a solenoid. I, that is current flowing through solenoid, and a rod of material which has net magnetization is placed inside solenoid. समजा या ठिकाणी हा रॉड आहे. Suppose this one as a rod of magnetic material which has net magnetization. हा जो रॉड आहे, हा रॉड आपण काय करतो, या सोलेनॉइड मध्ये ठेवतोय. If n number of turns, n that is number of turns per unit length, I current flowing through solenoid, mu naught permeability of air or vacuum, n number of turns, I current flowing through solenoid, mu naught permeability of free space, then in absence of rod, magnetic field inside solenoid, magnetic field inside solenoid, that is B naught is equal to mu naught n I, which is nothing but mu naught into h, where h is equal to n into I, called as magnetic intensity. हा जो h आहे त्याला काय म्हणतात, मॅग्नेटिक इंटेन्सिटी. Suppose this is equation number 1. Suppose this is our equation number 1. This is magnetic field inside solenoid in absence of rod. म्हणजे समजा हा जर रॉड नसेल, तर एवढं मॅग्नेटिक फील्ड तयार होत असतं. नाव if Bm magnetic field due to magnetic material, magnetic field due to magnetic rod, हा जो रॉड आहे समजा त्याचं मॅग्नेटिक फील्ड एवढं आहे, then experimentally proportional to magnetization of magnetic field, and magnetization of magnetic field is directly proportional to magnetic intensity. If Bm magnetic field due to magnetic rod, then magnetic field due to magnetic rod is directly proportional to magnetization, and magnetization is directly proportional to magnetic intensity. To remove this proportional sign, we have to take constant x. This is called as magnetic susceptibility, and therefore mz is equal to x into h. Put this value here, we get mu naught into mz, which is equal to mu naught into x h. Suppose this is equation number 2. This is magnetic field due to solenoid, and this is magnetic field due to rod. This is magnetic field due to solenoid, and this is magnetic field due to rod, and therefore total magnetic field inside rod, total magnetic field inside rod, B is equal to this magnetic field plus this magnetic field, that is B naught plus Bm, B naught mu naught H plus mu naught XH, which is equal to, समजा आपण इथं mu naught कॉमन काढला, 1 plus X into H. ही जी टर्म आहे 1 plus X is equal to mu R, called as relative permeability. Permeability X, that is relative permeability. Also relative permeability is nothing but permeability of medium to the permeability of air or vacuum. Relative permeability of material, that is permeability of medium to the permeability of air or vacuum. Put this value here, we get B is equal to mu naught into mu R into H. But mu naught into mu R, ह्या दोघांचा प्लॉट केला तर mu, that is B is equal to mu into H, where mu, that is permeability of medium, permeability of magnetic material. This is about magnetization and magnetic intensity. ओके, तर तुम्हाला फक्त एवढाच भाग सिलेबसला आहे. याच्या पुढचा जो भाग आहे तो पूर्णपणे डिलीट झालेला आहे. मॅग्नेटिक मटेरियल मध्ये फक्त तुम्हाला एवढाच भाग स्टडी करायचा आहे. काय काय स्टडी करायचं आहे तुम्हाला यामध्ये? एक म्हणजेच मॅग्नेटिक डायपोल मोमेंट ऑफ रिव्हॉल्विंग इलेक्ट्रॉन, गायरोमेट्रिक रेशो, त्यानंतर मॅग्नेटायझेशन, मॅग्नेटिक इंटेन्सिटी अँड मॅग्नेटिक फील्ड इनसाइड सोलेनॉइड ड्यू टू मॅग्नेटिक मटेरियल, that is B is equal to mu into H. Mu, that is permeability of magnetic material. ओके, एवढाच भाग फक्त आपल्याला स्टडी करायचा आहे. नेक्स्ट पार्ट ऑन नेक्स्ट पिरियड. ओके.